Hey folks, welcome back to another video. Today we're looking at question 78, subsets. The way we'll be solving this problem is by using a recursive approach where we add a given element that's given to us and try recursing again to create a subset out of it, and then we remove that element and try creating a subset without it. So let's get started. Let's call the method helper. And we need a couple of things. We need the array across which we need to create the subsets. We need the index, the current index that we're looking at, and we need a current subset that we're working on. So let's call that an array list. And then we need a list of integers, basically the type that should be returned. So let's create that. And let's just call this all subsets. New array list. Awesome. And then we'll pass this as well. And then in the end, you just need to return all of the subsets. Awesome. So let's actually create the main recursive method. We don't have to return anything since we will be referencing this all subset by reference. And we'll call this helper, and the parameters would be int, an array of integers with the name numbers, the index that we're looking at, the current subset that we're playing around with, and then the master list, so the list of integers, and then just call it all subsets. Awesome. All right, so let's get started. So with recursive methods, we need a base condition. So what is the base condition here? So anytime the index reaches the end of the array list, we know we cannot proceed. So we create a copy of that. It will be all subsets, and it'll be new array list, and then you make a copy of the current subset, and then you return. So why do we need to create a copy instead of directly adding it? That's because there could be other iterations where this helper method is being called and the same subset is being used. So instead of adding that subset to the list itself, you create a copy so that it's not contaminated or more numbers are not added to that. Awesome. So once you have the base case, what else do you need? So with the given index, you need to add that given element at the given index to the subset. So let's do that. So subset dot add nums of index. Right, so once you've added the element, okay, you know what? This is done. You call this recursively again. So it'll be nums index plus 1. You iterate it. You increment it by 1. And then the current subset. And then all subsets. But when it comes to all of this, when you have a given element, there are two possibilities. The possibility is that that element exists in the subset and that element does not exist in the subset. So we need to also remove it and try calling the recursive method on a subset that does not have that element. So what we do is we actually remove the last element, nums.size -1. Right, and you call this subset, this helper method again with the same parameters. You increase the index by 1, and send subset and all subsets. Awesome. So let's try compiling this. Ooh, what is the problem? Right. Let's try that again. All subsets. Oh, dot add this will be subsets of dot size, not nums dot size, because we're trying to access the last element in the subset. Okay, cool. So that passes the first few test cases. Everything works as well. Awesome. So let's talk about the space and the time complexity of the entire solution. So every single, as I previously mentioned, every single element has two possibilities, whether it exists or doesn't exist. So it is 2 to the power of n, and you have to do that for every single element. So it'll be n multiplied by 2 to the power of n. The same goes for the space complexity, because we have to store all of the subsets. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I really appreciate that. Thanks so much. I'll see you folks